Well, let's dive right in. Um,
Okay.
Zach, could you introduce yourself to the audience?
Hi, I'm Zach Hayden. I'm the Chief Mechanical Engineer here at AMBOTS.
Awesome. And AMBOTS,
Yes.
could you just describe for anyone who isn't familiar with what you do, um, who is AMBOTS, and what are you trying to
So,
achieve?
so AMBOTS stands for Additive Manufacturing Bots or Advanced Manufacturing Bots. We went with it because it can stand for a lot of the things that we do. And our goal is to do uh, swarm 3D printing, otherwise known as cooperative 3D printing, where different printers can work together to create more complex or larger objects than what a single printer can do to help expand the functionality and the technology of 3D printing.
Yeah, and I think what you guys are doing is so cool because 3D printing is awesome, but it also tends to be slow, which
Yeah.
creates challenges when you're trying to make larger and larger models. And so the idea of a swarm of robots working together to 3D print one part is just so cool. So I want to dive into that in more detail, but kind of focusing on you in particular, how did you first get started with 3D printing, and then how did you get involved with AMBOTS?
So back in around 2015, I got into watching 3D printing YouTubers like Joe Telling with 3D Printing Nerd and
Yeah.
Maker's Muse. Uh, yeah, I got really into that. Loved watching and learning about 3D printing. And then around 2017, I bought a Prusa 3D printer for
Okay.
myself to just start using things and start learning how like 3D modeling and all of that stuff works. And it was in 2018 that I joined AMBOTS as a researcher developing our new system that we currently have now. And that's where I got started with it.
Gotcha. Very cool. And so you said it started as just a research project and then became a company, or how did that work?
For me, it did start as a research project, but the company itself was founded in 2015, and that started also as a research project at the University of Arkansas as a senior design project. Some
Okay.
students wanting to do this type of technology came up with this idea.
Gotcha. Very cool. When you first got involved with AMBOTS, what was kind of your background that made you um, an asset to the team at that time?
So at the time, I was a senior mechanical engineering student at U of A, and I was trying to find a senior project and was hoping to find something related to 3D printing because of my interest in it. And found this project and started on with them developing they were transitioning from some of the smaller bots that we have on our website that look kind of like turtles,
Yeah.
these little bots, to making arms, robotic arms, to have them cooperate together because of just multiple advantages that they'd found to moving to something with a longer reach than something that had a fixed tool head on it.
Gotcha. They look like turtles. That's so fun. I didn't
Yeah.
make that I didn't make that connection. So kind of right out of school, you kind of joined the team and started
Hmm.
to
Yeah.
develop this further. Um, so starting from kind of that transition point, what did um, your I guess that's a great point to stop. Do you guys sell a product? Do you offer services? Or are you really just kind of research focused right now?
So we currently don't have a product. That's what we are currently working towards. We
Okay.
are actually in the process of selling our first dev kit, um, but we are more product focused. towards selling these systems to manufacturers so that they can produce objects themselves, either at a larger scale or different materials than they could otherwise use, is the goal.
Okay. And I'm sure it's so early, so it's hard to tell. But if you had to guess, what industries or what types of companies would you see benefiting from a system like yours?
So what we're looking into is going into precast concrete with construction, because currently what they use is things like foam cutters and CNC machines to make these large molds. They have been wanting to get into 3D printing, but the problem is with large scale 3D printers, they do exist that can print at the scale that they want, but they also have really large nozzles,
Hmm.
which lead to just really tall layer heights, really rough finishes, which means that after they print things with a large scale 3D printer, they have to go back in after it's printed and CNC the whole thing,
Gotcha.
which adds this whole step of the process to get the mold that they want. And the goal with ours is, since we're using regular sized printing nozzles, we can get the much finer resolution that they are wanting, and we can help bridge that gap between the high speed of a large scale 3D printer and the high detail of a like desktop 3D printer by having them cooperate with each other.
Gotcha. Okay. That's so cool. I think tooling is such a big, broad category depending on the
Uh,
industry and who's talking about it. But um, the concrete 3D printing space, I think, is usually like 3D printed houses. Um,
yeah,
but it seems like such a more practical step to make the tooling and focus on like the precast industry, especially for what you guys are doing. Um, so the project has been going on for what seems like a really short period of time. If it really just started in 2015. Um, so what did kind of those early days look like? The turtle bots, if you will. What were those like?
so the earliest prototypes that we had that actually got to a stage where people thought we were going to sell them,
Okay,
because they ended up being very polished, but their functionality was very limited.
okay,
So they were a bot on wheels that could roll around for printing for X and Y, and the only like normal axis they had was the Z to get layer heights.
okay,
Uh, but and the idea was that all these small bots would work together, printing really small, what we call chunks, to build up larger objects. Uh, But the thing was that with wheels, like actually driving around to print, the accuracy of that can be very difficult to uh, make like reasonable and
yeah,
acceptable,
I'd imagine.
because yeah, dealing with just like rubber wheels on even a like well controlled like area is difficult to get the precision needed for what they were aiming to do at the time.
Okay,
So the concept that went into when I started was they were moving to fixed robots that didn't move while printing, but instead they had an arm that gave them that XY reach so that they could cooperate together without moving, but while still being mobile, where they could be carried around to different locations and set back down and fixed in place.
okay. So like fix robot arms
Mm-hmm.
coordinated together. And then I think the one that I'm most familiar with is there's a really impressive video of two different robots kind of docking and moving to like precise locations and working together. I think maybe to make that honeycomb pattern behind you. Yeah. Yeah. What can you tell me about that version? Is that where you guys are at today, or have you moved on past that?
The version in that video, in our most recent video on our channel, is very close to what we currently have. We've kind of polished that up and got it ready to sell basically for a limited amount of customers so that we can get it out into the world because that's the stage we're currently at is we need feedback from outside people to continue building on this and to continue learning where we're going to go and what improvements we need to make. Uh, but the one in the video is pretty close to where we are now. But once this development kit gets sent out, we are going to be starting our next version towards a more commercial approach and more commercial target.
Okay. Um, and so looking at the robots and the dev kit that you have today, um, can you break down some of the specific capabilities, like what materials, what build area does it cover, how many robots are able to collaborate together?
So the individual print build volume of each arm is a 300 millimeter cube.
Okay,
Though since it is an arm, it can reach further than that. It's a 440 millimeter arm, so it can reach like a semicircle around itself. But for individual printing, that 300 millimeter cube, but working together, they can print 300 millimeters tall, but infinite XY as the is the goal with that is infinite XY with just a fixed height right now. We haven't figured out how to get rid of the limited height yet,
sure.
but that's hopefully a goal in the future. But the arms themselves mount onto a floor so that they can be fixed on like a grid system, and the build plates themselves can be taken up and put down so that those are modular as well. So you can just lay those out on your floor wherever you want to print and just tell the printers to go print there, and they can start a print of any size that you want. And they're carried around by a bot that we call the transporter. That's the little vehicle that you see in the video,
Okay,
and it can pick up the printers and move them around all while the printer's never turning off so they don't lose their positioning and all of that. So they can be shifted around on the floor tiles and on the grid so that they can print more chunks or can print other prints. If you want to automate like a queue of prints, you could set it up to where they move around to start other small prints.
okay. So the
Um,
transporter bot, when it's moving one of the arms, I'm assuming the arm pauses printing, right? And then it moves from uh, square A to square B, and then it goes from okay, I was printing chunk A, now I am moved and have to start printing chunk B.
yeah, everything turns off. The heater turns off to make sure it's cooled down for just safety reasons. And after it finishes a chunk, it's completely finished that G code file. Like it's no longer running that file anymore. And
Okay,
it's just in kind of a communication mode where it's talking with the transporter to coordinate that move. But then once it moves to a new location, it starts a new G code file so it can start the next part.
okay. Um, Tell me about the transporter bot. How did you kind of solve the challenges around uh, the positioning, right? Because it still moves on wheels. So I imagine there's some carryover challenges of just using rubber wheels versus using the transporter.
So the original bots that we had that printed on wheels, those used an optical sensor similar to what's in like a computer mouse to move around,
Okay.
whereas what we use now uses IR sensors for line following.
Okay.
So the positioning there is a lot easier to control since you can control the spacing of the sensors and the width of the line to make sure you can get the movement tolerances you need to get everything lined up for mounting the printer onto the floor.
Okay, that makes sense. So really, just by upgrading the sensors that determine its position, you're able to get that accuracy where it needs to be. Um, and so when you drop off one of the arms at a position, how does it mount to the floor? I'm guessing it isn't just weight driven, right? Like it probably secures itself in some way.
Yeah, we've gone through a few different versions of how it actually locks onto the floor, but it uses like ball bearings to align itself with grooves in the floor so it can get some precision alignment without being able to move while it's mounted.
Okay.
And then it locks itself down with a servo motor to basically grab onto the floor and hold itself there while it's printing.
Okay. Very cool. Um, what materials are you guys using today?
Currently, we've only tested PLA because that's the most general use case filament.
Yeah.
We've tested some like fill filament, like wood fill, and a bit of like copper filled filament, but mostly sticking to PLA for now. In the future, we would like to support completely different like tool heads on the arms, just
Okay.
so it's not just normal FDM printing. Things like laser cutting, CNC, and some other things that are being researched here with like resin-based printing. So like
Okay.
extrusion-based resin, not like normal.
Like a VAT process, not that.
Yeah, not like a vat process, like an actual extrusion-based resin. Which those are all a little further away with the resin being the furthest, but that's kind of the goal for different materials and different tool heads is to help expand the functionality with things like that.
Gotcha.
To yeah,
Um, so more of like a tool changer approach.
yeah,
Um,
that's the idea. Is it will have like a tool changer station that it can swap out tools at. Though that's something we don't currently have. That is in the works. So
sure. Uh, I'm sure you have plenty of things that are in the works
yeah,
that you may or may not be able to talk about, and that's totally fine. Um, so right now you have two arms that work together.
currently the floor that we have is only large enough to support two arms working together. We have three arms, and we're currently in the process of making a much larger floor so that we can have a lot more arms working together. But that won't be until like the end of this year, early next year, that we have that to show off.
Okay. Yeah, because in theory you could have three, four, 10 different arms all working together. Is that possible?
Yeah. So if you had an object that was, say, about 10 feet long, you could have five robots working together on that. It's basically the longest dimension of the object divided by two is the number of, uh, or yeah, number of bots you can have is the like number of chunks. So like each chunk is about 300 millimeters long.
Okay.
So it's basically the larger the object, the more you can have working together, and the faster it will go.
Right. Because I imagine if you had too many bots trying to work on a single small part, like they'd run the potential of bumping into each other, which would ruin everything.
Yeah, we currently have the limitation that they cannot sit directly next to each other.
Okay.
Um, so we avoid that problem of the collision potential by always having a build plate that is empty in between them so that
Gotcha.
they can never collide.
Gotcha. Um, when talking about the different chunks of a model, do you segment the models manually in something like Mesh Mixer or magics where you're doing like plane cuts to separate them into pieces, or is that done more on the slicing side?
It is done alongside the slicing in our own software. So when a user uploads a model, they place it on the build plates that they want to print on. They can assign the bots to it. But then when they go to slice it, the slicer will kind of analyze that model and see that, oh, this object is placed across three build plates. We need to split this up into three pieces. So it sends it to a piece of software we call the chunker that chops up that model using planes and different preset geometries to break it up into those chunks. And then each chunk is then sliced into its own G-code file.
Okay. Very cool. See, that was part of my concern is I imagine that being trained to segment models specific for this very unique system and then having to do all of that manually in CAD or at the mesh level would be really difficult of a learning curve. But you
Yeah,
guys kind of solved that already with the Chunker software, which is such a fun name. And is that cloud-based software?
yes, it is like a desktop application that we can run, and the chunker is just a small part of the entire user interface that you don't really ever see. It's a background task similar to how you don't see what a slicer is doing when it
Right.
is slicing an object. The chunker just runs in the background alongside the slicer to chop up the model.
Okay. And then how do each of those individual G code files make their way to the correct bot? And then how do the bots talk to the transporter? I realize I'm asking multiple questions at once. I'm sorry. It's how my
It's
brain
okay.
processes all
So
these things.
yeah, but this is it's all part of the process. So after each chunk is sliced, they are scheduled. So the software will take the bots you assign to the job, and it will take the G-code files, and it will upload the corresponding G-code files that each bot's going to print to that bot, along with like all the move commands it needs and all the communication it's going to have to do. That all gets uploaded to the bots, and then the bots uh, talk to the transporter via Wi-Fi through a control hub that kind of controls all the communications between all the bots and is basically like a traffic control tower that all the bots talk directly to it, and then it sends out all the commands to everything for what to do. So that's how they communicate with each other and how they coordinate all their moves and printing the chunks.
Okay. So cool. I kept envisioning like a USB cable running from one of the arms back to the transporter, but then that wouldn't really work because then the transporter has to move on the floor. But communicating over Wi-Fi to like a control tower is such a cool way kind of around that communication gap.
Yeah, that was part of the main uh, difficulty with making all of this is that there can be no wires. Like
Yeah.
everything has to get power like from the floor. It has to be able to communicate from wireless sources because since everything's moving around, we can't have wires connected to anything.
Yeah, so to that point, each printer arm doesn't have a power cable like connecting it to a wall, so it pulls power from the floor
Yeah,
that it
they
operates on.
yeah. So when you sit a printer down, like the printer themselves has no battery, no power supply in it.
Okay.
You just set a printer down on the floor, and it has contacts embedded in the floor tiles that it makes contact with and gets powered from. And similar to the transporter, it has a charging dock that it goes to charge its batteries. And while it's transporting a printer, the printer is actually powered from the transporter so that it never loses Wi Fi connection.
Gotcha. Man, that's so cool. Um, it's all of these like really specific challenges to what you're trying to do that you just don't see in other 3D printers or really any other um, industrial equipment, I would say. Usually you're operating within a box and the box gets plugged
Yeah.
into the wall. And so you kind of have that as a constraint, but almost like a constraint that makes your life easier, right? Because you have
Hmm.
power in one place. You don't have to operate on kind of this infinite plane.
Yeah. That's one of the main things we're trying to accomplish here is to remove the box from the 3D printer. So if you want a printer that can print something small, you can have a printer that prints something small with just a single arm. If you want something to print large, it can just continue expanding since it's all modular out to whatever size you want it to make.
Yeah, very very cool. When you look at kind of this journey that you guys have been on since the last 6 years, is there anything that jumps out to you as like this was the biggest challenge that like the team has faced?
So I would say the biggest challenge is trying to actually calibrate the arms.
Okay.
Because with Cartesian printers, you have just X and Y, and they're linear. The only thing you have to calibrate with them, if anything, is the steps per millimeter to make sure it's moving the correct distance.
Yeah.
But with an arm, there's so many other variables to it since it's not linear, it's all rotational axes. And since the printer's mounted to a floor, it doesn't know exactly where the build plate is, like when you set it down. Like it has to all be calibrated for that. And that was probably the largest challenge we've had to overcome is figuring out how to do all the calculations to get it to figure out all these variables and figure out where it needs to print to be in the correct location.
Gotcha. Yeah, I can imagine that would be pretty difficult. To your point on like most i3 style printers, like it's just one axis, all completely isolated from another. The acceleration um, can be exactly the same across that whole axis. When you start dealing with or polar coordinates, it's already much more
Yeah.
complicated. Even if it was just in one spot, let alone multiples. To solve that, did you guys just develop calibration processes that you knew would get you the right result, or did you implement sensors to like give you feedback to help calibrate it, or how did you overcome that?
So we are currently working on adding sensors to help with all of this. That's something I can't go into too much,
Sure.
but the main thing is just the math behind it. So Scaras have their own like equations to translate between Cartesian and Scara coordinates, and it's trying to get all the parameters that go into those coordinates to match up with the real world by just taking like real world points and making a solver that you can put those points into, and it calculates out all the parameters for the arms. That's the main thing we've made is just a calibration tool or solver that can take real world coordinates and translate them or correct the arms to where they match up with those coordinates correctly.
Gotcha. Very cool. So not just we're still doing all the calculations like by hand or with a calculator, but you have a tool that helps you
Yeah,
get from uncalibrated to
yeah,
calibrated much more quickly.
yeah. That took a long time and a lot of just manual calculations for a bit, trying to figure out what things do what, like what variables change what things, and how
Yeah.
to get them to all work together to make something that has high tolerances and good precision.
Yeah, that's I can relate a lot to that being a big challenge because with our printers we print on an angle. And
Mhm.
so it's not quite the same as a Scara setup, um, but it still is much different from just a
Yeah,
traditional. This motor moves this thing in this direction, right? So it is
yeah,
more complicated, and you kind of have to do those calculations and like run through it a few times manually before it becomes more clear of what's important, what's not, what you have to measure to get good
yeah.
results. Um, Again, looking at your journey as a whole, was anything easier than you expected when you look at your development process and how you got from where you first started to where you are today?
Something that was, I guess, surprisingly easy was making a tool head that can actually print in the ways that we want. Because since this is cooperative printing and it's chunk based, the printers have to print like right up against a previously printed object.
Yeah,
So, and like a normal tool head is usually pretty big. You can't print right up against another object with that. So, and what we needed was something that could print directly next to an 80-degree slope.
gotcha.
So, like something nearly vertical, all while being moved around on an arm. And what we have is more or less a custom version of a E3D volcano that's just a lot longer
Okay,
and a lot narrower. It's a
a
lot
lot
thinner.
pointier on the end.
Yeah, it's a
Okay,
it's a very pointy volcano hot end, so that we can print right up against other objects to so that they fuse together as they're being printed.
yeah,
Uh,
very cool. I'm happy to hear that that was easier than
yeah,
expected.
we expected that to be extremely difficult to be able to get those angles, but uh, hot end itself isn't really that large. It's usually all the things that go around it, like the cooler and all of that, that take up the most space. But other than that, it's just kind of trimming down the profile that we needed to achieve. So it was mostly just figuring out the dimensions that that nozzle needed to be, and everything else just kind of fell into place from that.
Gotcha. Yeah, I completely agree with you. The hot end itself is usually pretty small, pretty lightweight, but then you have the heatsink fan and the part cooling fan and the
Yeah,
whole extruder uh, assembly.
yeah.
So it adds up very very quickly. Um, from the software side of things, do you guys develop everything internally, like the chunker and the software that communicates from bot to bot to bot? Is that all internal, or do you have software partnerships?
Everything is internal. We have two software people that work on all the programming, the UI, and communication.
Okay, very cool. That's always just something that, again, when I first saw the video, I was like, how do they possibly talk to each other? I didn't know if there was something like out of the box that someone could pick up and use. But it makes sense that this is such a new technique that it would have to be kind of developed internally. Um, Looking at kind of the 3D printing industry as a whole, um, FDM, resin, tool changing, all these different things. Is there anything that stands out to you that you don't like about 3D printing, or that you think is kind of annoying in the industry? It's a high level question, so I'll keep talking while I give you a minute to think. Um, some things that annoy people are how annoying it is to change a nozzle, right? Because you have to hold the heater block, you have to
Yeah,
unscrew it. It has to be hot. You have to hot tighten it. I always get a leak somewhere in that stack of heat
I've
sink
had
to
that problem a
nozzle.
lot. Yeah, that's no fun. That can sometimes be hard to diagnose if it's slow, and it'll just
Yes.
like you'll just like suddenly see like drops of plastic on one of your parts and be like, "Oh, where'd that come from? Is
Yeah.
there something wrong with the extruder?" It's just no, it's just leaking.
Yeah, it was fine 30 hours ago, but now it's
Yeah,
just a slow leak.
yeah.
That
One of the things that I wish 3D printers had that was easier to do is multicolor or like full color. Um, that's something I really wish was a thing that was a lot easier to do. There are companies that are doing that with a few different methods, but doing things in full color um, cheaply and
yeah,
reliably are two things that I wish were a lot more accessible because I think that could really do a lot for just multiple kinds of models and like being able to not remove a step of post processing of just the painting aspect if you're wanting to make like a full model or a full color model.
yeah. I like that answer because to your point, affordable and reliable. Um, Often those two things uh conflict with one another when you're making like
Yeah,
a new product. Um, but also painting when you're trying to make like multiple parts becomes uh quite labor intensive. Um,
yes,
if you're looking at post processing. Um, yeah, full color is always such an interesting area because part of my brain is like, oh, it'd be awesome, no post processing, it totally makes sense. But the other part of my brain is, um, the most common color of 3D printer filament is black.
yeah,
Like it's used by
exactly.
engineers that
Yep.
don't usually care about color. So I think it's such a fascinating, I guess, topic within the world of 3D printing. Um, but very cool. Um, Outside of kind of what you're trying to accomplish in your products, what's one thing that you're really excited about in 3D printing? So this could be a trend that you're seeing, a specific technology that you think is really cool, or just something that you want to see more of.
Something that I can to have a tool changer with multiple
Uh,
colors or
I lost the connection on you. So
okay,
really just at the beginning when you said something that
okay, you can hear me now?
I can hear you now. You're good.
Okay, yeah, I think internet blipped there for a moment here.
Yeah. It's that's what life is like these days. So
Yeah.
no no worries.
So I saw recently that E3D has made a tool changer system. Cannot remember the name of it,
Okay.
but it's a system for having multiple extruders or different tool heads entirely in its own system, and so much so that they don't even call it a 3D printer anymore. They call it a motion system,
Gotcha.
uh, so that you can have like a laser cutter and a CNC and a 3D printer all on the same system, have it all swap between those automatically. And I think that's one of the next big things printing because I've seen several companies doing similar things with like tool changing so that you can have one machine that does multiple things so that you don't have to have a 3D printer and a CNC and a laser cutter. You can have one machine that does all three um, just for complete manufacturing from one system.
Yeah. Um what they're working on is so cool and it definitely seems really early for that type of machine. Um do you think it's more useful for it to be like an all-in-one machine? Like I'm laser cutting paper or I'm 3D printing or I'm doing CNC? Or do you think it's more useful when all of them kind of work together on a single part?
I think it would definitely be more useful if they all work together, because then you could have a 3D printer print an object and then just immediately CNC like a cleaner finish onto it or design into the object. And but it does have a lot of value just as an all-in-one, because if you don't have a lot of space, you could have a large system that does all three and does a large area of all three without taking up a huge amount of space.
Yeah, it's it's interesting because sometimes I look at all-in-one machines like a Snapmaker is the probably the
Mhm.
most popular one that comes to
Yeah.
mind. How you can do all three individually, and then
Mhm.
I always question like that take on things. I'm like, so is it just a mediocre 3D printer, CNC, and laser engraver? Would it not be better to have one machine dedicated to doing each thing really, really well? Um, it's an interesting it's an interesting topic, I think.
But if they can all work together, then it's adding a uh, new dimension to everything.
Yeah,
If they can actually work together.
yeah, I agree. I think the tool changing aspect and combining additive, subtractive, uh, pick and place, quality control, like that
Yeah,
idea has so much potential.
yeah, because that could open up a lot of things. Because like you could CNC a piece of wood into like a base and like laser etch an engraving into the wood and then 3D print something on top of that base. So you make like a statue or a trophy that's completely finished.
And completely automated, right?
Yeah,
Like you don't have to move the wood from one machine to another. You
yeah.
don't have to do multiple different job setups. So cool. um, I know we're wrapping up the end of our time here. So I'd give you the floor to invite people where they can learn more about you, where they can learn more about AMBOTS and what you're trying to accomplish, or if there's anything specific that you'd like the audience to do. Now's your chance.
So you guys can check us out at ambots.net is our website. That's the main place you can find out more information about us, get in contact with us, and see most recent like news updates about us are all on there. Um, yeah, that's the main place you can find us is on our website.
All right, I will make sure to link to your website in the description wherever people are watching or listening. Um, I'm wishing you and the rest of the team the best of luck in your development. I think what you're working on is just really really cool, and yeah, thanks again for taking the time to chat.
Yeah, thanks for having me. It's been great.
Thank you so much for tuning in to my chat with Zach from AMBOTS. It was so cool to get to feature a company that is doing something that no one else is working on. It's such a cool kind of niche of 3D printing, and I'm so happy to be able to share what they're working on with all of you. I will list their website in the description wherever you're watching or listening. Make sure to go check out some more details of what they're working on. If you haven't already, please consider subscribing to this channel, again, wherever you're watching or listening. It helps us grow and you won't miss episodes when they come out every single week. Thank you again for watching and happy printing.